Hey everyone, and welcome to Dr. Abu Art-In Academy channel. Today we are going to discuss part 2 of the seminar number 2 in the University of Debrecen, which mainly will be some practice and example of the first part. In this example, we have given two sets by description. It's not by numbers, not 1, 2, 3, 4, 3, 5, 7, or 11, 13, not by elements. We have given by description. So the set A is the first year students, okay, at MHSC, and the set B is the Norwegian student at the same university or school, okay, and these are the probability of A of being first year students, and this is the probability of being Norwegian, and this is the probability of the intersection, okay. So in order to understand any questions, the probability of A given B, just to remember the formula, probability of A given B. So I'm looking at the probability of A. I have to identify first what I'm looking for, probability of A, and given what is the thing which is confirmed or assured in my problem. So here in this example, what is the fraction of the first year students is Norwegian? We can read it in a different way or another way, just for clarity. What is the fraction, okay, is Norwegian? So he's looking for the fraction of the Norwegian, okay? But he gave us that they are first year students. What is the fraction of first year students? So this is not choice for us. He is not asking about whether they are in the first year or not. No, he told us it is given they are the first year, and I'm looking at the fraction of the Norwegian, okay? So here, what I'm looking for, the probability of what? Probability of Norwegian. Probability of, what's Norwegian? I can write in, okay, probability of Norwegian, given that they are in the first year. Or I can use the notation. It's better, of course, to use the notation given the problem, but here just for me to wrap up my mind, okay, the probability of Norwegian. So what he's looking for, the probability of Norwegians, which is B, probability of B, and what he has given that they are first year, A. So the probability of B given A equal probability of B intersect A, divide the probability of A, the last one. Be careful, if you swap them or made a mistake here, all the answer will be wrong. You have to identify which one he's asking about, probability of what, and which one is given. So the probability of B intersect A equals to the probability of A intersect B. They are the same, intersection. Probability of A intersect B, same as probability of B intersect A. Both are the same, okay? So here we can get the probability of A intersect B. This is called A intersect B, which is 0.015. Divide the probability of A, which is 0.24. So my answer will be 0.0625. Okay, 6.25%. In the second question, he asked, what is the fraction? What is the fraction in the first year? Okay, so I want the probability or the fraction in the first year, okay? But given that they are Norwegian, what is the fraction of Norwegian? So there is no choice for this. I don't want the probability of the Norwegian students. I want he gave me that they are Norwegian. But the fraction of being in the first year. What is the fraction of being in the first year? But they are Norwegian. There is nothing here in this problem except the Norwegian, okay? What is the fraction of Norwegian student in the first year? So it is given that they must be Norwegian, but what is the fraction of being in the first year or second year or third year or whatever? So this is the problem here. So here I have to understand exactly what he's asking for. He's asking about the fraction of being in the first year. What is the fraction of Norwegian in the first year? So his question, what is the fraction in the first year? Given that I want only the Norwegian, okay? So the probability of I want the probability of being in the first year, and given that they are Norwegian. So what is the probability of first year here? Was A. B Norwegian, B. So it will be equal to probability of A intersect B, or AB, divided the probability of B. Okay? So probability of A intersect B or B intersect A, 0.015 divided 0.05 equals 0.3, which is 30%. Okay? if you notice here, the percentage change highly, okay? Because here he's asking about the Norwegian in the first year. He's asking here that there are first year students and at the same time they are Norwegian. But here he is asking the other way around, okay? That they are Norwegian, but they are in the first year. So just for clarity, so here he's asking about the fraction of being Norwegian, and he's asking the fraction of being in the first year, okay? So the denominator for both of them will be different. Numerator will be the same, okay? Because he's asking about the same thing, but the denominator will be different. He's asking about the fraction, okay? The fraction is something in the numerator and denominator. Always here, probability of A intersect B, okay? In Norwegian and first year student, or first year student and Norwegian. But the one which differs, this fraction is divided by what, okay? Like for example, if you have a profit, you have bought a car and there's a profit of, for example, $1,000. This $1,000, I ask you what is the fraction or the percentage of this profit to the original price or the selling price. So you can divide it by the original price and give me the percentage, and you can divide it by the selling price, which is higher, and give me another percentage. It is the same case or the same scenario, just for your understanding. Here in this slide, before proceeding with other examples, he just gave us a hint here that if A and B are independent, then the probability of A given B equal the probability of the first one only, okay, or probability of A. So how would this happen? The probability of A given B equals the probability of A intersect B, right? Divided the probability of B. So probability of A intersect B, this one, divided the probability of B. I know that the probability of A intersect B equals the probability of A times the probability, because both of them are decimal, less than 1. Probability of B times, okay, not plus, times the probability of B. So I can replace probability of A intersect B by probability of A times the probability of B. So let us erase this one. So here the probability of B. So we can replace the probability of A intersect B by probability of A times probability of B divided the probability of B. So probability of B will cancel probability of B. It will be equal to probability A. And this actually, it makes sense. The probability of A given B equals the probability of A only. He's looking for the probability of A. Or for example, of being Norwegian or being first year. So it is the probability of A of being Norwegian, or if he has got the probability A being Norwegian, so that's the probability of being Norwegian. Probability of A being first year, it's the probability of A being first year student. So it doesn't matter. So, but subject to, there is no overlap between them. There is no intersection. So I don't have Norwegian in the first year, or I don't have first year in the Norwegian students, okay? If there is no overlap, if they are independent, this means that, or they're not depending on each other. If the first one happened, the second one can happen. For example, if I toss a coin, okay? If I toss a coin, so either the tail or the head. If the tail comes, the head cannot happen. One of them only has to appear. So this is called dependent. They are depending on each other. If one happened, the other one will not happen. But subject, they are not independent, so this case will be applicable. Probability of A given B equal to the probability of A itself. Actually, it is the question itself, it is the probability of A. And this is just a condition. It's equal to probability of A. That's it. Okay? And this is the proof of it. So if he asks me, check the independency of two events. If these two events are independent or no, I can use this formula. If the probability of A given B equal the probability of A, this means that they are independent. If the probability of A given B is not equal the probability, okay, if the probability of A given B equals to probability of A, this means that they are independent. If they are not, if the answers, for example, here 0.5 and here 0.2, so they are not equal, so they are not independent. So they are using this rule to check the independency of the two events, A and B. If they are dependent, they should be equal. It should be equal to the first one. Probability of A should be equal to probability of A. Probability of A given B should be equal to probability of A. So here also give us another hint. If A doesn't depend on B, and event A does not depend on event B, hence the event B also will be independent from A. So here they are independent on each other. But here, as we can see, there is no intersection between them. There is no intersection. Like the head and tail, there is no intersection. But here, he said that he asked a question. Is it given that this must be independent? No, it is not. As I give you the example of the tail. If the tail appear, the head cannot appear. So they are depending on each other. Although they are disjoint, there is no relation between them. But here, if you can see the question which is asking, are these events independent? No, they are not independent. Why? No, they are mutually exclusive. Mutually exclusive means disjointing. There is no joint, no overlap between them. They are calling mutually exclusive. Mutually exclusive, but they are not independent. If one of them occurs, the other one will definitely not occur. Okay? Because they don't have intersection. Okay? So if one of them occurs, the other will definitely not occur because they don't have intersection. So the occurrence of one doesn't have the effect of the occurrence of the other one. Mutually exclusive events are not independent. So this is called the rule of independence. So if they are independent from each other, the probability of A intersect B equal the probability of B times the probability of A, because they are independent. Independent that if one of them happened, it does not impact the happening of the other one. Okay? Independent. If they are independent, we can apply this rule. But the mutually exclusive event, they are not independent. Okay? They are not independent. Like the head and tail. Okay? One of them happened, the other one cannot happen. If one of them occurred, okay, because they are mutually exclusive, either this or that. Okay, one of them happen, the other one will not happen. Here, let us assume I have a group of people, 4 groups of people, and I have a disease. The group of people, okay, and they have a disease called A, for example. So I split my group into group B1, B2, B3, B4. My disease, if it happens or spread between them, so it will have a portion in the group B1. It will have a portion in P1 and a portion in P2 and a portion in P3 and a portion in P4. The total fraction of this disease will be equal to the fraction in P1 plus the fraction of P2 plus the fraction of in P3 plus the fraction in P4. Okay? So here the definition is called marginalization and Bayes-theorem. In the event B1, B2, and B3, they are mutually exclusive. See B1 and B2, mutually means each two of them, they are exclusive. They don't have any intersection. Okay, just side to side. B3 and B4, the same thing. B1 and B3, B4 and B3. So they are mutually exclusive pairwise. So each pair will be mutually exclusive. So B1 and B2, this pair, okay, will be mutually exclusive. B2 and B4 will be mutually exclusive, and so on. So here, if I have events P1, B2, B3, and P4, okay, and I have the total probability of B1 plus P2 plus P3 plus P4 equals to 1, okay, and I have the intersection between B1 and another disease or another criteria is A, B1, okay, so this is the disease, the portion which we have in B1. So this is the intersection between the disease A, for example, and B1. The disease A with B2, the disease A with B3, the disease A with B4. So the probability of the disease, the overall probability of the disease, it will be the disease happening in A1, in B1, this is happening in B1, happening in B2, and the portion happening in B3, and the portion. So this portion of the disease happening in P1, this portion of the disease happening in P2, the portion of the disease happening in P3, the portion of the disease happening in B4. So the probability of A will be the sum of the probability of A intersecting B1, A intersecting B2, A intersecting B3, E intersecting B4. Okay, so here because the intersection is the part of it is part of B but which has A. Okay, so it's part of B but the one which has the disease A. So this is the portion for the disease in the section B. This is the portion of the disease in section P2. This is a portion of the disease in P3. This is a portion of the disease in B4. So the total probability of the disease equals the probability of AB1 plus AP2 plus AP3 and so on. So by knowing, in short, by knowing the probability of A intersect P1 and A intersect P2, A intersect P3, and the intersection between A and the other sections, I can get the probability of the disease itself overall, okay, from the intersections. So intersection of this one plus this intersection plus this intersection plus this intersection. So it is called marginal because I have here A, B. I removed the part for A from here, the part of A from here, the part of A from here, the part of A. I removed this margin of A from everyone and add them up. I get the probability of A. So it was A, B, A, B, A, B, A, B. And I removed A and got the probability of A. I removed this margin from it. So here, using what we have taken previously in the relation between the given A and the given B and the intersection, we can arrive to the Bayes-theorem. Bayes-theorem said that, okay, let us first have the derivation of Bayes-theorem, then we'll understand it. Okay, if you remember, initially we said the P intersect, probability of A intersect P is equal to the probability of B intersect A. So A intersect B means equals the probability of B intersect A. Both of them are equals. Okay, so B intersect A equals B, the probability of the probability of A intersect B equals the probability of B intersect A. The probability of B intersect B, A intersect B equals the probability of A given B. This was just what we have taken the previous example, the previous slide. The probability of A intersect P equals the probability of A given B times the probability of B. The probability of B given A, it will be the probability of B given, just to change this one to given A times the probability of A. Since the probability of A intersect B equals the probability of B intersect A, so both are equal, so also the right side of the formulas will be equal. So the probability of A given B times the probability of B equals the probability of B given A times the probability of A. So I just equal the two sides of the formula, okay? So this is the side of the probability of A intersect B. This is the one, okay? And this is the probability of, so here if we look at this, so the probability A intersect P equals probability of A given B times probability of P. Probability of P intersect A equals the probability of B given A times the probability of A. Left side equals the left side. The probability of A intersect P equals the probability of probability of A intersect P equals the probability of B intersect A. So the right side also will be equal to the right side. So the right side for the first formula here will be P A given B times probability of B equals the probability of B given A times the probability of PA. Okay, I need to have this one as the subject of the formula, so I'll make it probability of P given A would be equal this side divided probability of A equals B A given B times the probability of B divided probability of A. And this is the formula which I'm looking for, okay? So I can switch. If I have the probability of A given B, I can use it to get the probability of the B given A. And if I have the probability of B given A, I can use it to get the probability of A given B. So let us write it here and I teach you how to memorize it. So in order to memorize it, just here we write, based on this one, the probability of B given A equal probability of A given B times the probability of the first one, which is B, divided the probability of the second one. We can have it here. So probability of B given A equals the probability of the swapping, okay, of the A A given B. Instead of B given A, it will be A given B, okay, times the probability of the first one in the denominator and the probability of the second one in the denominator. Okay, so we can use the same principle if we have A given B to convert it into B given A, or B given A and to convert it into A given B. So just we'll swap them. So probability of A given B, it will be exactly the probability of A given B. Instead of B given A, it will be A given B times the probability of the first one in the denominator divided the probability of the second one. So that's it. If you want to memorize it again last time, so just swap them, probability of A and B here, okay, probability of A given B. The probability of B will be in the denominator, probability of the second one, the given, it will be down in the denominator. So here in this example, it says that 20%, okay, 20% of particular age group has hypertension. They have high blood pressure, okay, hypertension. So the probability of having high blood pressure or hypertension equals 20%. Or 0.2 equals 0.2. This is the probability of having hypertension, okay? 5% of this age group has hypertension and diabetes. What does it mean, hypertension? And so both of them. So the probability of having hypertension and diabetes equals 0.05, okay? We can write it in this way, or we can write the probability of HD, like times. You remember we said intersection, we can write next to each other, 0.05, okay? Okay, so here, given that an individual from this group has a hypertension, so this is given. So the probability of something given that he has hypertension. But what is the probability of what? Okay, from the, has given that he has hypertension, what is the probability? This is what I'm looking for. Probability of what? Probability that the individual has diabetes. So what is the probability is of diabetes is what he's looking for, given that he has hypertension. Okay, so I write the formula of this. The probability of D given H equals the probability of D intersect H. Okay, if you want to write it this way, divided the probability of H. Or you can write it probability of DH instead of intersection, probability of D, probability of H. Okay, as you like. So the probability of DH or D intersect H or H intersect D 0.05 divided the probability of H. I don't have the probability of H. Do I have? Yes, I have. I wrote the first one here. The probability of H is 0.2. So 0.2. So it will be equaling 0.25. Okay, so this is the probability of the person is diabetes, given that the probability of diabetes given that he is hypertension as well. Okay, I hope this one is clear. Forget about this solution number 2, it is a little confusing. Solution number 3, actually, it is also a good way to solve it. So we can say here that, okay, I have 20% of the particular group has hypertension. So I can answer this problem in this way. I have two characters, hypertension and I have diabetes. So I can say hypertension, the one who has hypertension, it will be H positive. The one who doesn't have, it will be H negative. And diabetes positive, diabetes negative. And then I'll put lines here. Okay. And here I will have the total. Here, down here, I have the totals. Okay. So the total number or the percentage of the people who are having hypertension is H positive. Okay, these are the people who are having it. So the total of them, he did not say having hypertension and diabetes or not diabetes. He said having hypertension only. So this should be the total. Okay, the total should be 0.2. Okay. So the people who doesn't have hypertension, If the people who has hypertension 0.2, the people who doesn't have should be 0.8. Okay, I don't know why I have this line. I should not have any line here. Okay, so if the people who having hypertension are 20%, the people don't have should be 0.8 or 80%. Then he said me 5% of this age has hypertension and diabetes. So hypertension and diabetes. So here in this area, 0.05. From this one, I have the total 0.20 or 0.2, okay? And the diabetes only 0.5, so the non-diabetes, because these two has to sum up to 0.2, okay? They have to add up to 0.2. So this one will be 0.15. So 0.5 plus 0.15 equals 0.20, okay? So this problem is not a complicated one. It is a simple problem, because it will come to some cases where we have figures here also and we have to calculate all of them. So it will be in the next example. But here in this example, it is a very simple case. So we have the people who are diabetes 0.05, okay, 0.05, okay, and he told me what the probability that the individual has also has diabetes, and he's from the group which has hypertension. So the hypertension, the total number of the hypertension is only 0.2. It's not 100%, it's 0.2. And he's 5% out of this. So he's 5% out of the 0.2. So he's 5% or 0.05 out of the 0.2%. So it will be equaling to, it will be 0.25. And this is the same answer, I think, which we have got in the last page, which is this one. Okay, so they are the same. Okay, I think the best way is just to start and work based on the first solution, because the second one is confusing, and third one, it is not confusing, but it has some deep thinking. So I think the best way or the simplest way to use always the first solution. So here in this example, in a town, 48% of teenagers have a bike. Okay, so 48% has, each one of them has a bike, okay? So the probability of having a bike is 0.48, and 39 of the teenagers have both bike and skateboard. So this is the intersection between bike and skateboard. We can write P intersect S or P or BS, okay? BS or B intersect, both of them are the same. So this is the intersection, which is 0.39. What is the probability that randomly selected teenager has skateboard? So he wants the probability of skateboard. The probability that teenager has skateboard, given that, okay, so given that he or she has a bike, okay. So here, what I can do, I can say probability of B given, of S given B equal the probability of S intersect B divided the probability of B. So do I have the probability of S intersect B? Yes, I have the probability of S intersect B or B intersect S. They are the same, okay? And the probability of B, I have it also. So the answer will be the probability of B intersect 0.39 divided 0.48, which will equal 0.8125. Okay, I hope that this one is clear. Forget about the second solution. So this one is straightforward. In this example, I'll show you how to think about the problem, and then how to get the data, extract or get out the data from the problem. Some of the data which I will write here now, it will not be used in this problem, but it is common it might be used in other problem. So this is just the way how you can extract the data. So it is mentioned here in a Drosophila, the fruit fly, okay? The population, in the Drosophila population, 25% of animals has I mutation. So I consider I mutation, this is the first event or criteria which I have. I start with E, so I'll use E letter. E positive means has mutation. So 25% of the animal has I mutation. So the probability, of the I having mutation equals 0.25. So also we are not going to use the additional data in this problem, but in some other problem we're going to use it. So we can say the probability of E negative not having mutation should be the complementary. If having a mutation in the I 0.25, so it doesn't have mutation, it will be 0.75. The same thing here, 50% of the wing has of the wing mutations. So the Drosophila, okay, have 50% have wing mutations, so the probability of wing positive having mutation 0.5, so the probability of the wing negative doesn't have mutation 0.5. Okay, then he said here, and 40% of the animal affected by I mutation, so it is given that already affected by the I mutation will also have wing mutation. So the probability 40% having wing mutation, probability of wing mutation positive, W positive, given that they already affected by the I mutation. It's already given 40% of the animal affected by the I mutation. It's already given to us that they already have the I mutation, and this is their probability of having wing mutation, but they already have I mutation. So I positive, okay, equals 0.4. So what is the probability that randomly selected animal will have at least one mutation? Will have at least one. Here at least it doesn't mean that normal or traditional at least, which we have at least two. So we'll say, okay, if it's at least two, this means that 2, 3, 4, 5, 6, 7, and so on. So we can, instead of going to infinity, we'll say at least 2 means 1 minus the other way around. So the one which doesn't have, it will be 0 or 1. So 1 minus the probability of 0 or 1. If it is at least 3, so 3, 4, 5, 6. So rather than going from 3 to infinity, we'll work it the other way, the complementary. Okay, if they don't have, it will be, if at least 3, so if you don't have, it will be 2, 1, and 0. So 1 minus the probability of 2, probability of 1, probability of 0. So this is the traditional at least. But here this problem is not the same. So here, what is the probability that randomly selected animals have at least one mutation? So because in this problem itself, I have two mutations. I have I mutation and I have wing mutation. So he said either, he should say that they have either I mutation or wing mutation or any of them, okay, which is the intersection, okay, but at least they should have one. They may have two, because at least they may have two, they may have one of them. So what he's talking about, he's asking for the probability of I mutation union P union W mutation, okay. So the probability of E union W, or sometimes they call it E plus W. You can call it E plus W or A union W. It doesn't matter. Okay. We have intersection, or they are disjoint. They are disjoint, or we have intersection. Of course, we have intersection. In this problem, he said some of them had this and had that, and what is the at least that they have common. So we have intersection. So we have to use the general formula. General formula for union, if I say P E union, just to change the bracket, make it more clear, okay. The probability of E union W, or E positive union W positive, will be equal the probability of the first one, it's union probability of E, plus the probability of W minus the probability of their intersection, the probability of E intersect W, okay, or EW, as you like, okay. Probability of E, we have it already here. Probability of W, we have it already here. Probability of E intersect W, I don't have it, but I have the probability. So probability of E intersect W, it could be written as probability of W intersect E, okay? They are the same, intersection, okay? So probability of W intersect B, I don't have it, but I have the probability of W given E. Can I convert probability of W given E to W? Yes, we have taken the previous slide. So the probability of Okay, let us write the probability of given. Although I have given already the direct formula, but I showed from the beginning. Probability of W given E equals the probability of W intersect E divided the probability of the second one, probability of E. So we can have cross multiplication. So the probability of W intersect E will be equaling the probability of W given E times probability of the last one, probability of E, which is the law which I have given the last slide. So we can use this one. We have already probability of WE, we can use it, and we have the probability of E. We can get the probability of W intersect E, and we can substitute in the formula. So P W given E 0.4 times probability of E 0.25 equals 0.1. Okay, so this is the probability of P W intersect E, or WE, as you can probability WE. Okay, 0.1. So I can use it here, 0.1 divided the probability of E, which is 0. So I have to use it here. So probability of E equals 0.25 plus probability of W 0.5 minus the probability of the intersection, which is 0.1. So 0.25 plus 0.5, 0.75 minus 0.1 equals 0.65. Okay, and this is the answer which I have here. I hope that it is clear.